तो अभी
लाइव हो गया।
अच्छा हाँ ये हो गया ना, अब इसमें
हो गया।
लाइव हो गया। साहब बस यूट्यूब पे जाएं तो लाइव है ना, वहाँ पे लिखे हैं अभी NED CSIT वो ये कंप्यूटर साइंस नहीं सिर्फ CSIT कंप्यूटर साइंस एंड इंफॉर्मेशन टेक्नोलॉजी।
कंप्यूटर साइंस
इंफॉर्मेशन टेक्नोलॉजी
टेक्नोलॉजी
जी
सर्च करो।
जी सर्च करें।
चलिए
ये लो।
अच्छा
हो गया था।
अच्छा
चेक करने की आवाज़ आ रही है इसका वॉल्यूम।
ठीक है काजी मुझे कॉल कर देना।
अब ये जैसा नजर आ रहा है थोड़ा सा अरे वो आएगा इसमें
Bismillahirrahmanirrahim. Respected Chairman, Department of Computer Science, Dr. Muhammad Mubashir Khan, our distinguished guests, faculty members, and my dear students, Assalamu alaikum and a very good morning to all of you. Let's start today's session in the name of Allah. For recitation of Holy Quran, I would like to invite Muhammad Sahib.
أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. سبحان ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين. صدق الله العظيم.
Subhanallah. Today we are gathered here for a discussion on adversarial machine learning. Our speaker is Dr. Anum Paracha, who is serving as a lecturer at University of Wales. Her research interests are to investigate use of adversarial machine learning techniques to mitigate emerging cybersecurity research challenges, and particularly strengthening the resilience of ML against adversarial attacks. Without further ado, I would like to invite a guest speaker to start the session. Please give her a warm welcome. Thank you, Thalia. Assalamu alaikum all. I hope you are doing well and interested about this new emerging topic, adversarial machine learning. Okay, so without further delay, my name is Anum Paracha. A bit about myself. I'm a lecturer at University of Wales, Trinity St. David, UK. My research interest is particularly to mitigate machine learning, adversarial attacks against the machine learning model, and what type of adversarial attacks we will see today. Okay? And before that, I have around 6 years of experience in research in cybersecurity. And before that, I was working in one of the MNC in Karachi for 4 years. So, how many of you have used machine learning models? Please raise your hands. I'm anticipating almost, if not all, most of you, right? So, and how many of you know that your model is secure and trustworthy? Any? You don't know. So what is the emerging thing? We particularly use machine learning to strengthen our cybersecurity models, our cybersecurity solutions, healthcare solutions, and various other security sensitive systems and solutions, right? But this emerging use of machine learning attract adversely to attack the machine learning models themselves and harm the integrated system. Okay? So for example, previously we are trying to strengthen our cybersecurity solutions against the cyber attack. But what about the machine learning attacks? If someone attacks a machine learning model and we don't know that our cybersecurity solution is secure or is not, that domain is called adversarial machine learning. Okay? It is one very important thing about the concept of adversarial machine learning. It's not only consisted of adversarial attacks, but of the mitigations as well, the defenses. So these two aspects combined being called adversarial machine learning. In today's session, we will particularly focus on adversarial attacks. There are further different categories that we will see in which adversarial attacks can be categorized into, and we will focus on one type. So this was a taxonomy I have created around 3 years ago, where I have tried to categorize the attack types, the adversarial attacks, and further categorize the ways in which it can happen. Okay? So at first, machine learning models or machine learning, it basically comprises of three types. The simple one. I'm not going into the complex one, the deep learning. Just think about the simple machine learning. It can be a supervised, it can be unsupervised, it can be reinforced, right? And adversarial attacks are implemented on all of them. Further to that, these machine learning models can be a simple machine learning model, can be a federated machine learning model, can be a reinforcement one, can be defended, can be mitigated, or secured machine learning model as well. So adversarial attacks are that strong that they are able to breach the existing defenses against those attacks. Further to that, okay, we have seen on what type or what architecture can be attacked by these types. But what are the categories of adversarial attacks? There are four major categories. What are those? The poisoning attacks, the evasion attacks, inversion attack, and model inference. Okay, we will see. I will explain you these types, defined basically in one slide next. It can happen on the data, that can be the raw data, that can be the training data, that can be the test data, and it can happen based on the knowledge and the capability of adversaries. How much access do they have towards the model? Now, let's see how those attacks types are categorized. First of all, can anyone know, or can anyone define what are the basic phases of machine learning model? Anyone? Yes.
Collection of data,
Yes.
then training the model, then testing its accuracy, and then deploying it.
So basically, it's the three phases of developing a machine learning model. We start with training, and then we test and validate it, and then we deploy. So based on these three types of machine learning model, the attacks are categorized. If or an adversary can manipulate the training data set, that is called the data poisoning. Okay, so it will manipulate the whole pipeline of the model, starting from training. If someone or adversary can manipulate the test time data, that are called evasion. That is one of the part of inference as well. Further to that, if you know, I think all of us have used ChatGPT at least once, right? So if we query ChatGPT with some inference queries, and the ChatGPT is a deployed model, that is called the inference. Sometimes the inference queries are trying to extract the details of the model to replicate it. That is another type of inference attack, which is called model inversion. Okay, so these are the 4 categories in which these adversarial attacks are categorized. But we will focus on data poisoning. Okay, that is the first line of attack that manipulates the training data set. Now, the attack can be on black box. Black box attack means, like any of the 4 categories which I described before, this can be a black box attack. Black box attacks means when the adversary do not have any knowledge about the data or of the model. Okay. So, for example, about the ChatGPT, if you don't know about the training data set, you don't know about the testing, its internal configurations, okay, and you are trying to infer it or you are trying to poison it, that is called black box attack. That is the most realistic scenario where we are anticipating that the model is completely unknown to the attacker. The second one is the gray box attack, where we are anticipating that that the adversary or the attacker have some knowledge of the data set or the model. Okay, and that is the part of our session later. Why? Because considering that we are mostly using public data sets, or sometimes when we know the domain, okay, we are developing a model for skin cancer or something like that, we can anticipate what kind of data set we have used. That is called gray box. The last one is the white box, which is the intrinsic attack. Intrinsic attack means where we are anticipating that the adversary has the complete knowledge of the data set and of the model. Now, focusing on data poisoning attacks, a very simple attack of data poisoning is label flipping attack. Consider you have an intrusion detection data set available. Okay? It has two categories. It has either the label of 0 or the label of 1, right? Simple, in very simple words, if the adversary can change some 10% or 15% of the data set, we cannot know, and we don't have any particular method to identify how much labels are correct and how much are not. Manually, we cannot go even for a simple 10 feature data set to manually identify if the labels are manipulated or are not. And we are using public data set, so it's very realistic. Okay? But focusing on this kind of data set attack or data poisoning attack, we have seen realistic scenarios where the model performance is disrupted across like around 50% or more than that. So what we will do in today's session, what I'll explain you about my research, we'll focus on this simple label flipping attack at the moment, and we will focusing on the gray box approach, where we are just anticipating that we do have access to the data set, considering that the data set is publicly available. For example, if you go to the Kaggle and you have access to the data sets, right? And no one knows that how much is the data set is reliable or is not. Okay? There are certain websites, for example, if you go for one of the very prominent data set is ISIC, that is used for in skin cancer diagnostics. That's an image data set and it's publicly available, but we don't know how reliable it is. And even just poisoning 10%, it can harm severely to the human life. So that is our approach. Now, we know that, okay, with level flipping attack, a simple data poisoning attack, we are able to downgrade the performance of the model. Now, what's the point of doing it again? What's the point? The point is that during my work, I had the same kind of question, that if this attack is already available, some mitigations are available, although some are already reachable, but what is the point of doing it again? The point is that we understand that the performance is degrading, but we don't know how the performance is degrading and why the performance is degrading. Okay? Even with simple label flipping attack, I will come to this one first, but let me give you a brief background. With simple label flipping attack with same data set, if you train RF model, random forest, okay, and you poison the data set by 10 to 15%. Okay? Its accuracy decreased by around 5 to 7%. With the same data set, if you train a decision tree and again poison with the same poisoning level, the degradation of accuracy will be different. That's the point. Why? I'm not saying that their accuracy should be equal for RF and for decision tree, but the degradation is different. That is the point of concern. That why we should understand how this poisoning is changing the internal mechanism of the models. This is where I developed an approach which is called deep behavioral analysis. In this approach, what I did, I selected 4 cybersecurity datasets, including CICIDS 2017, UNSW 15, and 2 others. And I implemented this level flipping attack starting from 0% to 25% at a scale of 5, means 5, 10, 15, 20, 25. And I poisoned 6 different models, including SVM, decision tree, Random Forest, GNB, and perceptron, a simple perceptron, which is the simple neural network. And what I try to identify for each of the model how their internal mechanism is changing. For example, I'll give you answers later on as well. For example, for RF model, how their feature importance score is changing at certain levels of poisoning. For similarly for decision tree, for KNN, how their nearest neighbor is getting impacted with poisoning level. If I change the KNN, the nearest neighbor in KNN, how the poison can be mitigated or how the poisoning impact is mitigated. Similarly for all 6. So this is what I set up. I conducted it for 6 machine learning models, which I said, for 4 data sets, and I tried to analyze the different aspects of machine learning models, including their variance as well, how the variance is changing. So these are some of the basic results. I'll give you the paper as well, in which you will see the deep like the detailed results about it and their implications as well. These are some of the other results in which you can see the accuracy for SVM for all 4 model is different for same level of data. The how the data distribution is changing with this simple poisoning and how it is impacting when the data structure is changing. So this is the if you wanna go through the paper, just go through this table first, and you will see what is the relationship between individual model parameter and the poisoning levels, poisoning impact. So for SVM, I have seen that for simple label flipping, SVM has less impact considering other models. If you see DT, the decision tree, the feature importance score are getting impacted very highly with the change in with this poisoning. Similarly for KNN, if I increase the number of case, the number of neighbors, it is decreasing the poisoning impact. Why? Because we are averaging the k nearest neighbors to identify the the label or the categorization of the test instance. This is how I try to identify that the poisoning level is impacting the individual parameters of the model. What is the purpose of this study? This study has provided me a very deep background of understanding the relationship between poisoning impact and individual parameters of the models. Later on, considering this, I have generated one new attack, which is called OOP, the OOP attack, which is outlier-oriented poisoning attack. And on that, I have conducted these 2 industrial case studies to highlight what is the significance of this new poisoning against the existing mitigations. If you see the first one, which is the skin cancer diagnostics, it is with one of the company in US, who has developed a case study and an application for diagnosing the skin cancer using the lesions, the skin lesions. And using their same data set, I just poison it with 10% of my poop attack, and it has highly degraded their performance. And it's not only about degrading the performance, but in these kind of security sensitive application, if you have increased the false positive rate even for 1%, that has a very huge impact on human life, where it is cancerous and it is marked as not cancerous. I have conducted the second case study on this 5G test bed, which is a test bed to optimize the usage of network between Wi-Fi and the 5G for NRU, for the recycling facility. And that has also been degraded a lot with this simple pointing attack. And the point is that the existing mitigations are getting failed. So before going towards the mitigation, the core summary is that we should first understand how the poisoning is impacting the models and how, so we can develop a good solution to mitigate such attacks. Because, for example, a very simple case, a very simple attack that I have explained, which is label flipping, we can have a lot of mechanism to change the data set. Even one feature of the data set can degrade or can include a backdoor in the model, and we don't know. If you design, for example, if I design a simple solution to mitigate this label flipping attack, an attacker can have more opportunities to poison my data set with any other type of attack. Yeah? So we first need to understand the internal mechanism and how poisoning is changing the internal mechanism, so we can develop a strengthened solution. Now it's time for a challenge. Can anyone has any questions so far? Yes.
Why attacker do adversarial machine learning? What are the advantages?
What
they
are the
getting?
advantages? Okay. So the student asked the question about what's the benefit of adversarial attack, right? So if I ask what's the benefit of cyber attack? So the adversary can have different kind of intentions. For example, for simple skin cancer diagnostics, it can be on national level, it can be on individual level. They want to harm just to prove themselves, like we see in the zero-day attacks and all such things as well. On the other hand, there is one very sophisticated type of attack as part of poisoning, which is called backdoor. They insert a backdoor as part of poisoning, which later on they utilize for their purposes, like to trigger that backdoor for their use case, which is not detectable. You getting? And it's
The performance we are talking about, is it like during inference or during training? I think,
Hello.
because I think during training, it may increase as well or remain the same because we are training on that particular dataset which is already flipped. So the performance we are talking about, is it during inference or during deployment during the training?
so for the poisoning attack, we poison the data set, which is the training data set, but the outcome we will see during the testing or the validation. Okay? So this outcome is during with the clean data set, which is the testing data. But what we did, we poisoned the training data set, trained the model, saw the accuracy, which is decreased on the testing data set. Okay?
Somehow the attacker has changed the distribution of the data. The network is trained on one distribution and it hasn't seen the actual distribution, and during deployment it is seeing the actual distribution. And
Yes, yes. Even for your second part of question, which you say that even the flipping can improve the accuracy, it may improve the accuracy, but it may not, like accuracy is not the hard fast rule to judge a model or to like to calculate the efficacy of the model. It is the precision, it's the recall, underscore, variance of the model. There are certain other factors. Accuracy is one of them, but accuracy is not the real identification of the performance of the model. Okay?
सो एक इसमें मेरा क्वेश्चन ये था कि नॉर्मली जो पब्लिक डेटा सेट्स होते हैं फॉर क्रिटिकल एप्लीकेशंस वी डू नॉट चूज पब्लिक डेटा सेट्स टू ट्रेन तो इसमें आप क्या करें स्पेशली इन हेल्थ सेक्टर तो अटेकर के लिए ये तो इट्स अ वेरी सिंपल एग्जांपल कि वी हैव टेकन पब्लिक डेटा सेट एंड हैव लॉन्च्ड दैट सो अटेकर इसको अगर or normally when we have a during training we don't have just a training data set we split it into validation and testing data set और आप ये कह रही हैं कि सिर्फ ट्रेनिंग को वो मैनिपुलेट कर रहा है तो इसको मैं ये कहूँ कि ड्यूरिंग ऑफलाइन जो आप काम कर रहे हैं वो जो भी डेटा सेट है उसको पूरे को वो पॉइजन कर रहा है एंड डिप्लॉयमेंट के वक्त ऑफकोर्स वो डिफरेंट हो जाता है और फिर ये भी कि जो हेल्थ सेक्टर में स्पेशली हैं उनका डेटा तो वो रिलीज भी नहीं करते और वो इंटरनली अभी भी यहाँ पर आसाम में जो रिसर्च चल रहा है उनकी इंटरनल चल रहा है बाहर को किसी को एक्सेस नहीं देते
अच्छा इसके ऊपर तभी मैंने एट द स्टार्ट ही कहा था कि फॉर दिस केस स्टडी आई कंसीडर अ पब्लिक access to the data set, but it can be an intrinsic attack. The point is that how successful these attacks are. If someone who is from the internal of an organization can have the personal features, can have certain other conspiracies to do these kind of stuff, they can easily do it. And we don't have any successful mitigations that resolve these issues, these attacks. That's any other question? Yeah.
How can we detect such type of attacks?
Good. So that's the next part of this topic, which is like we do have certain solutions. A very common one is data sanitization. Okay, we do sanitize the data set, and that's a very generic word which I'm saying, the data sanitization. There are various ways of sanitizing the data. What we are doing, we are grouping the data and then training the models and then cleaning it, and then based on, for example, on one group it has high variance and then we are averaging it with the other group, with the third group, sort of federated learning. That is one of the solutions. The other very interesting solution is adversarial training. If you want to learn about adversarial training, is very good solution. What we do, we know that these are the existing attacks. We implement such attack. It's like a vaccination. We implement such attack by ourselves, but in very low sensitivity. Yeah, sorry, intensity. Like 0.01 of the gradient, or like just 1% of label shifting, and then training the model again. So the model can understand how the adversarial data looks like. So at random or at inference, if there is such attack is getting implemented, even during training, so that is able to be detected by model itself. So we are improving the internal resilience or robustness of the model through adversarial training. जैसे हम वैक्सीनेशन के टाइम करते हैं ना, वैक्सीन क्या होती है? वैक्सीन उसी जर्म का एक बहुत ही लो इंटेंसिव पार्ट होता है जिसको हम बॉडी को देते हैं ताकि उसका इम्यूनिटी बूस्ट हो जाए. इसी तरीके से हम मॉडल्स की इम्यूनिटी को भी बूस्ट करते हैं. बट इन दिस स्किन द प्रीवियस in this skin cancer diagnostic application, I implemented the adversarial training against my OOC attack, and it fails. The adversarial training fails. Why? Existing adversarial training is able to secure neural networks, which is the core focus at the moment in machine learning and in the domain. But we forgot about these baseline the SVM, the distributed, which are very important, especially when we have limited resources, like limited data set, when we are trying to capture the network traffic, for which we already have the features available. We don't want to go for a deep learning or a neural network. So in that kind of models, the adversarial training won't work. Why? Because in neural network, it works like in batches. Like after a batch, it calculates the gradient, it improves the resilience. It calculates the gradient, improves the resilience. But in SVM or in decision tree in random forest, we don't have such batch learning. Okay. Any other question?
reinforcement हमारी जो लर्निंग होती है उसमें जो हमारा मॉड्यूल था वो एनवायरनमेंट क्लास से करवाता है लर्नर तो उसमें ये सवाल है कि जो डेटा पॉइजनिंग है वो उस इन्फोर्समेंट लर्निंग में एप्लीकेबल है या नहीं कि एनवायरनमेंट क्लास से वो अपने आप को बेहतर कर रहा हो
इसका एक बहुत सिंपल सा आंसर है यस व्हाई नॉट अच्छा रीइंफोर्समेंट लर्निंग में भी आप अगर जाकर देखें ना तो जेल ब्रेक्स अटैक जस्ट एग्जांपल they are very successful against GPT which is one of the reinforcement learning models okay एक छोटी सी एग्जांपल दे सकते हैं केस स्टडी कि आप रीइंफोर्समेंट लर्निंग के दौरान आप एक क्वेरी देते हो जो बैकडोर है उस मॉडल के लिए वो जाके उसने बैकडोर इंजेक्ट कर दिया उसके बाद द एडवर्सरी knows about that backdoor कि उसको किस तरीके से ट्रिगर करना और किस तरीके से यूज करना है जिससे जो उसने डिजाइन किया बट फॉर अ सिंपल यूजर इवन फॉर द प्रैक्टिशनर्स दे डोंट नो अबाउट दैट और इवन वो एक और ज्यादा वर्स्ट केस है कि वो आपकी परफॉर्मेंस को इम्पैक्ट नहीं कर रहा तो वी डोंट नो उसको तो डिटेक्ट करना और भी मुश्किल होता है आई होप इट्स आंसर यस
Yes, my question is that how adversarial attack becomes successful. Like for example, if an attacker modifies some data that is available on public platform, so we call it as poisoning attack. But the genuine person, like for example, if I need to download something, if I need to train my model, I will download from the official source. So the adversarial data that is modified by the attacker, that is just kept on the attacker's side. That is not being modified from the official platform, from the genuine platform, we call it. So how the genuine person will fall into the trap of downloading that fake data?
Okay. So that example, don't confuse yourself that is only possible with the public data set. That's only one case study that I have taken for this deep analysis, for deep behavior analysis. Okay, that is one of the case study or one of the possibility. But what happened for the intrinsic attack, which are definitely an idealistic scenario, but it's possible. It's not like that someone from within an organization or someone to have access to your model. It's very similar to what we are doing with it during the cyber attacks. How the cyber attacks are happening. Like the intrusion. And even these adversarial attacks can be integrated with the cyber attack to be implemented on the system. Is it clear?
Okay, I have one question. Can we identify the poisoning attack by checking the distribution of the data? Normally, हम machine learning में देखते हैं कि the distribution of data during inference is changing, generate errors. It means we need to update the model. So in this case, also during training, one distribution which is poison data distribution, it has been used for training. But during inference, the data will not be poisoned. So it means that distribution will be different. So can we, this is one possible way of detecting.
There are certain solutions which follow this mechanism or this thought, like the federated learning, for example. In that, what they are doing, they are creating the chunks of the data, train multiple models, and identify which has a different, like the variance, identifying the variance, and then they are averaging the model. That is one of the solutions. However, for a simple backload or when you are pointing very like one person, I can give you one more example. There's one more paper if you want to search. It's subpopulation attack. In that, what they did, they have injected a complete cluster of the poison data. It's something like, okay, there are 3 classes in a data set. You choose one class, you replicate it, change their label to the other class, and inject it back. So it's part of one class, features from one class, label from other class. How you can identify the variance in that scenario? That's another possibility. Any other?
I think we should move to challenge.
Okay, now it's time for you guys to do something. A very simple thing to give you a practical hands-on with this adversarial attacks. Okay, so what I explained, what I took is very simple case study, a simple, very simple attack which is label flipping. What you can do, you can just poison 10%. You can just change the label of 10% of your any of your data set. So what you need to do, identify any open source data set. What you like to do, select any model which you want to train with that data set. Okay, train the model, capture the performance outcome, accuracy, precision, recall, F1 score, not only one, not only accuracy, but the others as well, and particular FPR, the false positive rate. Okay, capture it, set aside. Now, poison your model with label flipping attack with like only for 10% to 15%. Okay, not more than that. Again, train the model from scratch, not the one that you have trained previously. Okay, retrain the model, capture their performance, accuracy, precision, recall, and F1 score. Okay, and then perform the deep behavior analysis. I provide you the resource part for that. Okay, and see how your model is getting impacted with that 10 to 15% of level flipping. Okay, and then try to capture or try to study it. What are the insights from that outcome? Okay, if it is getting changed, how? If it is not getting changed, then what? Okay, the resources for that is this one. There is a research paper which I written. Okay, it's published. You can access it. It's available to you guys from your NED email. Okay, there is a GitHub repository which is also linked in that paper, so you get the baseline code as well. Okay, some sort of help from that, so you can do your deep behavior analysis, and then we will discuss the insights maybe next month. Okay.
Miss,
Yes.
is this label flipping means flipping or manipulating the output of the data?
No, no, no. It's like, okay, it's for example, you have selected an intrusion detection data set. Okay, it has two labels in the whole data set. It's either 0, which is not intrusion. It can be either 1, which is intrusion. Okay, just randomly select 10% of the data set, like from any distribution. If the label is 0, change it to 1. If the label is 1, change it to 0. Flip it, and then retrain it and see what will the outcome. 10 to 15% means, for example, your data set has 100 instances, very, very short at the moment. So just change 10 or 15% of it. Okay? Just 10 to 15 labels or 10 to 15 labels of the instance. That's it. Okay?
Thank you so much for such an insightful session. Students are requested to please note down the challenge, and the challenge and the resources will be shared with you as well. And you're supposed to solve it. Final year AI and final year cyber students. Okay? And after you're done solving it, please report back to me, and we may arrange another session, maybe online with Dr. Anum, and we'll discuss some of the insights about it. Is that clear? Okay, thank you so much, Dr. Anum, for such an insightful session. I now request Dr. Mohammad Mubashir Khan, Chairman, Department of Computer Science, to please present a token of appreciation to our guest speaker.
मैं थोड़ा सा इनके Bismillahirrahmanirrahim. Mashallah, today we had one more session. yesterday we had a session also, and today's session is very special for me in a sense that Dr. Anam is the student of the Department of Computer Science. Okay? He did her masters from our department, and I remember the time when she was in my class, and I remember the time when she started master's thesis in our department. Okay? And the quality of work which she did was so excellent that on the basis of her research work in master's thesis, she got selected for the PhD scholarship in Birmingham City University. Okay, and soon after completion of her masters, she went to UK and she did PhD with a lot of very good publications and very good impact. And soon after that, as soon as she completed her PhD, she got a lecturer position in a university. I don't know the name of the university. University of Wales. University of Wales. So, mashallah. So this is a success story. ठीक है ना? So just for the for your information, for motivation, here you are also the students like her. ठीक है? And you also have all the opportunities open for you. ठीक है? So now it's up to you कि how much efforts you make, ठीक है, to make your career bright and very successful. ठीक है? So many students are here, and I don't know how many of you will sincerely do a lot of effort, ठीक है, and listen everything carefully, ठीक है, and following up on it, ठीक है, and then moving forward with flying colors, ठीक है. तो ये इस तरह की स्टोरी हमारे सामने मौजूद है बहुत सारी, ठीक है, लेकिन बताने का मकसद आप सबको यही है कि हमें आगे बढ़ने के लिए मोटिवेशन भी चाहिए होती है और कुछ सक्सेस स्टोरीज भी चाहिए थी जो हमारे अराउंड मौजूद है, ठीक है. एंड शी विल बी आवर एसेट in future as well, we can easily connect with her in future. Okay, these people are and not only her, there are so many other examples as well. They are always willing कि कोई हमसे contact करे and we help them. ठीक है? तो आई होप कि आप लोग फ्यूचर में इस कॉन्टैक्ट को इस्तेमाल करेंगे, इसको यूटिलाइज करेंगे, और ये लोग वहाँ पे जो कटिंग एज रिसर्च कर रहे हैं, काम कर रहे हैं, उसको आप यहाँ पे कैश करेंगे. ठीक है? तो विद दीज रिमार्क्स वी कंक्लूड दिस सेशन एंड इंशाल्लाह वी विल कंटिन्यू दिस विद मोर इंटरेस्टिंग सेशंस लाइक दिस. ठीक है? थैंक यू.
Students are requested to please join us for a group photo.